Hi guys, in this video I am going to talk you through a few more examples about covalent bonding. Just as I've been saying before, it really takes practice in order to build your confidence, build your skills, so be patient with yourself if you're struggling. That is the learning process. I want to take a look at a new example of nitrogen and hydrogen. I'm going to head on over to my periodic table just to see where they happen to fall. In this example, we're focusing on nitrogen, which is right over here, as well as hydrogen right up here. And I'm noticing that in this particular periodic table, they are both colored green, green referring to the non-metals. So automatically I'm thinking nitrogen is a non-metal, hydrogen's a non-metal. I'm expecting a covalent bond. Okay. Let's start by examining each atom individually. So I'm going to head back to the periodic table to gather some information about nitrogen. I see that nitrogen has an atomic number of 7, meaning it always has 7 protons. In a neutral nitrogen atom, that means it would have 7 electrons too. I'm also noticing that nitrogen is falling into group 15 or main group 5, meaning that I expect 5 valence electrons in nitrogen. So I'm going to take that information and I'm going to draw the Bohr model for nitrogen. Take a look, I have 7 total electrons, of which 1, 2, 3, 4, 5 are valence electrons. And I'm also reminding myself that, hey, nitrogen would be happy and full if we could get that second energy level to be 8 valence electrons. I'm going to do the same thing for hydrogen. Head back to my periodic table to gather information about hydrogen. I'm seeing that hydrogen has an atomic number of 1, meaning all hydrogen atoms have 1 proton in them. And in a neutral hydrogen atom, this would mean we would also have 1 electron. I'm also noticing that hydrogen falls into group 1, meaning that that 1 electron would be the valence electron. So I'm going to draw the Bohr model for hydrogen. There's my 1 electron total, 1 valence electron, just reminding myself that hydrogen, since it only has 1, the first energy level, will be happy and full at 2 valence electrons. Okay, so I've looked at them individually, and now I'm starting to think about how are they going to bond. We want everyone to be happy and full in the end. So how many atoms of nitrogen am I going to need? How many atoms of hydrogen am I going to need so that everyone is happy and full? Remember, nitrogen has 5 valence electrons right now, and it wants to be at 8. So we have a difference of 3 for nitrogen. Hydrogen has 1 valence electron, and it wants to be at 2 valence electrons. So we have a difference of 1 over there. Through some trial and error, and as you practice, you'll develop intuition. In this example, we will need 1 nitrogen and 3 hydrogens. And I'm going to circle where that covalent bonding is going to happen. The hydrogen and the nitrogen are going to share valence electrons. Covalent bonding is all about sharing. Same with this hydrogen sharing its valence electrons, and our last hydrogen sharing the valence electrons with nitrogen. This circle method can then lead us to draw the final product. Take a look over here on the right side of the screen. Notice how my circles, I've now drawn them next to each other. This is that sharing pair. That is our covalent bond. And I kind of like drawing it like this as the final product because then we can check to make sure everyone's full and happy. Let's first check this hydrogen. Remember, hydrogen's going to be full and happy at 2 because it's its first energy level. And I see 1, 2. 1 valence electron it already had, and this blue second valence electron is what's being shared with nitrogen. Because of this sharing, hydrogen is happy and full. Same down here with this hydrogen. 1, 2 valence electrons, it's happy and full. And over here with this hydrogen, 1, 2 valence electrons, it's happy and full. Shifting my focus to nitrogen, let's make sure nitrogen's happy and full too. It has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Nitrogen is happy and full as well. Because of this covalent bonding, everyone has ended up happy and full. Let's take a look at the molecular formula here. The formula for this is going to be NH3. N comes from nitrogen and has an invisible 1 subscript, but we don't even need to write it. H comes from hydrogen, and that subscript of 3 means that there were 3 hydrogen atoms. The name of this molecule would be nitrogen trihydride. Whoa, that is a fancy name. Let's dissect it. Nitrogen we put first. Nitrogen is the main atom here. So nitrogen comes first. The main atom always comes first. Now, you may be wondering, why is there no mono in front of nitrogen? After all, mono, the prefix mono, means 1 atom. Yeah, sometimes we drop the mono when it comes with the first atom. So instead of saying mononitrogen, we drop that mono. It's kind of invisible, it's implied, and we just say nitrogen. Then we have trihydride. Tri comes from the prefix for 3 atoms. So trihydrogen means 3 hydrogens, but of course we still ended in IDE, just like we did with ionic bonding. Nitrogen trihydride. In fact, you might already be familiar with this molecule. Nitrogen trihydride, or NH3, is a fancy way of saying ammonia. Let's head on over to our covalent bonding homework and do a few examples from there. Let's take a look at the table in question number 2. This table includes the element, the symbol, the total number of electrons in a neutral atom, the number of valence electrons in a neutral atom, and thinking through what would make that atom happy and full. Let's try to do sulfur together. I'm going to focus in on this column for sulfur. I'll head on over to my periodic table, and I'm going to find sulfur right here. Let's gather some information. Sulfur has an atomic number of 16, meaning that all sulfur atoms have 16 protons. In a neutral sulfur atom, that means there would also be 16 electrons. Let's record that. Going back to my periodic table, I'm noticing that sulfur falls in group 16, or main group 6. This tells me that sulfur should have 6 valence electrons. And finally, let's think through what we would need to make sulfur happy and full. Well, right now it has 6 valence electrons, and a full energy shell would be 8 valence electrons. So it needs 2 more electrons. Scrolling on down to number 3 in this worksheet. Number 3 says to draw a picture of the Bohr diagram of each atom. Then indicate using circles where the covalent bonding is going to occur. Include the correct number of atoms so that everyone's full and happy, and then write the molecular formula. I'm going to talk you through this example right here silicon and chlorine. Okay, so the first thing I need to do is draw my Bohr models for a silicon atom and a chlorine atom. So I'm going to head to the periodic table to collect some information. Finding silicon. Silicon has an atomic number of 14, meaning in a neutral silicon atom, we will have 14 electrons in total. I'm also noticing that silicon is in the group 14 or main group 4, meaning it will have 4 valence electrons. So I've drawn my Bohr model for silicon. 14 total electrons, 4 valence electrons, which means that in order to be happy and full, this atom is going to need 4 electrons. Let's do the same for chlorine. I'll head back to my periodic table to collect information. Chlorine has an atomic number of 17. That means every chlorine atom will have 17 protons, and for neutral chlorine atoms, it will also have 17 electrons. I'm noticing that chlorine is in group 17 or main group 7, meaning 7 of those electrons are valence electrons. Using that information, I've drawn my chlorine Bohr model. Now chlorine, in order to be happy and full, right now it has 7 valence electrons and it wants to get to a full level of 8. So chlorine will need 1 electron. Okay, so the question becomes, how many silicon atoms do I need and how many chlorine atoms do I need in order for everyone to be happy and full in the end? You'll develop an intuition about this as you practice more. You may have guessed it, you need 4 chlorine atoms and 1 silicon atom. I'm going to use circles to highlight the sharing. And these circles are going to represent those covalent bonds where the sharing of valence electrons occurs. I'm going to take those circles and use that as a guide to redraw the final molecule, which looks something like this. And in this final one, we can do a check to make sure that everyone's happy and full. Checking chlorine. 1, 2, 3, 4, 5, 6, 7, 8. Happy and full. 1, 2, 3, 4, 5, 6, 7, 8. Happy and full. 1, 2, 3, 4, 5, 6, 7, 8. Happy and full. 1, 2, 3, 4, 5, 6, 7, 8. Happy and full. All of our chlorines are happy and full. Let's check silicon. 1, 2, 3, 4, 5, 6, 7, 8. Happy and full. Because everything is happy and full, we know we have successfully completed this covalent bond. We have formed a molecule. So let's try to name that molecule. My main atom here is silicon. So that's going to be the first one that I write. And really, I have 1 silicon atom. So I could write a subscript of 1, but oftentimes we don't. It's like an invisible one. Chlorine are going to be my other types of atoms, and I have 4 chlorine atoms. SiCl4 is going to be the molecular formula. To come up with the molecular name, what we would actually say to each other, we need to consider our prefixes. Let me bring those up again. Here is our table of prefixes. So the ones that stand out to me right now are mono, because we had 1 silicon atom, and tetra, because we had 4 chlorine atoms. So writing this out, I would have mono, or 1, silicone, and tetra, or 4, chlorine. But we're not quite done yet. We need to replace the end of our second atom with IDE so that it ends in ide. Monosilicon tetrachloride. Another thing that we do is if mono is in the first atom's name, we usually drop it. It's almost like how there was an invisible 1 in my subscript up here. There's an invisible mono in the name down here. So really, we would say silicon tetrachloride. And that, of course, is recorded in number 3 on your homework. Silicon and chlorine combine to make SiCl4, silicon tetrachloride. Take a look at this little note here. We wanted to make a note because in class we talked about how covalent bonds happen between a nonmetal and a nonmetal. And if we take a look at our periodic table, I'm pretty convinced that chlorine is a nonmetal, but silicon's kind of in this weird category called the metalloids. Metalloids can act like metals or nonmetals. And so in this case, silicon, being a metalloid, is going to act like a non-metallic substance. So it's functioning as a nonmetal. That's why we're seeing this sharing, this covalent bonding. And last but not least, let's take a look at question 4 in your homework. Question 4 is all about that naming. So I want to talk you through this first example that's already included. Nitrogen plus bromine. Capital N for nitrogen and Br for bromine. Here we are given the molecular name nitrogen tribromide. Let's dissect this. Nitrogen, or capital N, has an invisible mono before it. Remember, when we start with mono, we often drop it, it becomes invisible. So this is telling me 1 nitrogen and then tribromide. Tri is the prefix that corresponds to 3 atoms. This is telling me that I have 3 bromines. Of course, notice it ends in IDE, telling us that this molecule has undergone bonding. So 1 nitrogen, 3 bromines. We would write that as N for nitrogen, invisible 1 that I don't even have to write, Br for bromine, with a little subscript 3, reminding me there are 3 bromine atoms. We've included the diagram to actually show what nitrogen bromide would look like in terms of Bohr models, where there's sharing going on between bromines and nitrogen. This is a helpful tool, especially for some of these problems. For example, these last ones where you're not given the name, so you don't know the prefixes. You don't really know how many of each molecule there are, of each atom there are. So you may need to draw out some Bohr models to help you understand how many atoms there are and therefore write your molecular formula and molecular name. I want to conclude with one last reminder that bonding and really learning any new content is going to take time and practice. So challenge yourself. Ask yourself if you're really understanding what goes on. Push through that struggle. Try to get yourself unstuck, because that's the learning process. And of course, know that your teacher is always here to help you. Ask questions, tag them in documents, come to office hours, because you can do this.